Good evening everyone, myself Gautam Sarma. I welcome you all in Sapiens Education. So this is part 3 video for the NCERT solution for the class 12. So here we go. Okay, so let's try to solve. So first of all question, we need to discuss the questions what they are saying. There is a polythene piece of a rubber with the wool is found to have a negative charge, right? Polythene piece rubbed with the wool is found to be negative charge. Estimate the number of electron transfer from which to which. So now let us suppose they have told that a polythene piece. So let us suppose this is a polythene piece, right? Is rubbed with wool. So this is a wool, and wool is found to be negative charge. So this is negative charge. So definitely this will acquire a positive charge. As we know that whenever electron will get transferred from any body, so it will acquire positive charge. So from here, electron will be lost by wool, and polythene will be gain polythene will gain same number of electron, right? Now they have told that charge acquired by the wool is found to be negative. So negative means polythene will, no, sorry, electron will be lost by wool. No, electron will be gained by the wool, right? So electron will be gained by the wool, and polythene will lose same number of electron. Estimate the number of electron transfer. So number of electron transfer. So we know that Q is equal to Ne. So number of electron is equal to charge they have given as 3 into 10 to the power minus 7 divided by 1.6 into 10 to the power minus 19. So this amount of number of electrons they have given. So number of electron will be how much? So let us calculate it. So this will be 330 by 16 into 10 to the power 12. 1.875 into 10 to the power 12 electrons. So from electron will get transferred from polythene to wool. Is there a transfer of mass of the wool? Yes, definitely. If electrons are moving, if electrons are getting transfer, so mass of electron will get transfer. And if you want to find what is the mass of the electron, so how you will find it? So we know that mass of the electron, we know that mass of the electron, so let us suppose mass of the electron is equal to it will be approximately 1 into 10 to the power minus 31. 9.1 mass of one mass of electron is equal to 9.1 into 10 to the power minus 31. So total mass of electron will be how much? Mass is equal to n into mass of electron. So number of electron is how much? 1.87 into 10 to the power 12. 1.87 into 10 to the power 12 into 9.1 into 10 to the power minus 31. So if you multiply it, so it will be very less mass. So basically what happen when you rub plastic with the wool, so what will happen, you won't find any desirable changes in a mass because it is very less. So definitely the solution should be that there is a transfer of a mass, but it is very less, that can be ignored as well as, right? I hope you have understood this one. Now let us go for next question. Now see, let us read the question first of all before solving. Two insulated charged copper sphere A, two insulated charged copper sphere A and B have their center separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion if the charge of each one is this one and the radii of the A and B is negligible compared to the distance? So let us suppose there is a two charge ball. So let us suppose this is a charge ball and there is another charge ball. So it has a charge of 6.5 into 10 to the power minus 7 coulomb, and it has also same charge, that is 6.5 into 10 to the power minus 7 coulomb, right? And the distance, we can say the distance is d1, right? So if you want to find out, so force of repulsion, so F is equal to K, distance they have provided you 0.5 meter, so F is equal to K Q1 Q2 by D square. So there K means 9 into 10 to the power 9 into Q1 Q2 means 6.5 into 10 to the power minus 7 whole square divided by D square means 0.5 whole square. So now just we need to find out the finally, if you find out the calculation, so how much it will be. So it will be approximately, just you try by your own so that you can understand it well, 1.52 into 10 power minus 2 Newton. So it will be approximately equal to 1.52 into 10 to the power minus 2 Newton, right? So I hope you have understood this one. Now, what is the force of repulsion if each sphere is charged double above the amount and the distance between them is halved? So see, the thing is that if each, what is the force of repulsion if each sphere is charged double the above amount and the distance between them is halved? So let us see. F, we know that F is equal to K Q1 charge Q2 charge divided by D square. As per them, Q1. So what will be the new force if charge, first charge and second charge get double? So this will be 2Q1 into 2Q2 divided by D square. Distance become half, so this will become D by 2 whole square. So finally it will be how much? So it will be 2 to the 4, 4, just 16 times of the K Q1 Q2 by D square. So this value itself is considered as a 16 into F. So F dash, that is new force, will be 16 times of the previous ones. So previous ones what we have got is equal to 1.52 into 10 power minus 2. So this will be 16 into 1.52 into 10 to the power minus 2. So basically if you multiply it, so how much it will come? So let's multiply it. 1 6 into 1.52. So this will be approximately 24.32 into 10 to the power minus 2 Newton. So I hope this is the new force, so you find it correct. I hope you have understood this one. So this is the best way to calculate. Now next we can go through the next question. The next question is that so let us read first of all question. In figure 1.30, so this is figure 1.30, shows the tracks of a three charge particle in a uniform electrostatic field. Give the sign of three charge. So let us suppose there is a charge 1, 2 and 3. Now if charge C, this is positive charge and this is negative charge, so definitely this both 1 and 2 will be negative because it has been attracted by positive charge. So charge 1 and 2 both are negative as they both are being attracted toward positive charge. Now third one is your positive charge. Why? Because they are being attracted toward the negative one. Now which particle has the highest charge to the mass ratio? Charge to the mass ratio Q by m, that is charge to mass ratio is directly proportional to the deflection of the charge, is directly proportional to the deflection of the charge, right? Deflection of charge. So let us see here which is maximum deflection. So if you observe this one 3, it is maximum deflection. So third charge, so from here we can say that 3 charge which is positive has highest deflection, so it has maximum charge to mass ratio. So I hope you have understood this well. So let's go for next question. Now in this question, first of all read the question properly so that you can get the insight of this question. So consider a uniform electric field E. So they have given you E electric field. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? So let us draw it. So let us consider we have three axes. So let us consider this is your x, this is y and this is z, right? Now they have told that what is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ. So if you take this plane, so this plane itself is parallel to the YZ. So it has the area vector will be which is parallel to the x-axis, right? So the theta between an electric field, if you just check it, the electric field direction, so it has an electric field direction. So what will be the electric field directions? Since it is electric field E, they have provided you as 3 into 10 to the power 3 I cap Newton per Coulomb, right? So the direction of the electric field is like this. So that is electric field is like this. Okay. So the angle between angle between area vector and electric field electric field is equal to 0. Theta is equal to 0. So if you want to find out flux, so flux, the formula for flux itself is equal to ea cos theta. So ea cos theta, so e is how much? 3 into 10 to the power cube into area. So area of the square will be how much? 0.1 into 0.1 meter square. So this will be 0.01 meter square. So this is the area of the square. From the data we can go. So this will be 0.01 into cos 0 will be 1. So basically it will be 30 Newton meter square per Coulomb is the flux, right? Now what they are asking, they are asking what is the flux through the same square if the normal or to its plane makes an angle 60 degree. So this means that in this part what they have given, in this second part theta they have provided you 60 degree. So what will be flux? So flux will be equal to ea cos 60 degree. So ea we have already got as 30 into cos 60 means 1 by 2. So basically flux will be 15 newton meter square per coulomb. So I hope you have understood this question. So is there any doubt? I hope you can find it easier to solve this type of problem. So next we will do for next question, that is 1.6 1.15. In what is the net flux of the uniform electric field of the exercise? See the question, try to read the question first of all. What is the net flux of the uniform electric field of the exercise 1.14 through a cube opposite this one, oriented so that its face is parallel to the coordinate planes? Net flux of the uniform electric field. So basically you need to understand the questions of what they are asking. In the fix in see in the fix in this they are saying what is the net flux of the uniform electric field of exercise this one through a cube of a side 20 centimeter. So there is a cube of a side 20 centimeter. So what will be the net flux inside this net flux? So before that we need to know that number of field lines. Let us suppose number of field lines like this, from any side it will go number of field lines entering will be equal to number of field lines piercing out, right? Piercing out, it means that same number will be coming out. So basically what happened, so net flux will become zero because whatever amount of electric field is coming in, so it will go in out. So it means that net flux inside this will become zero. I hope you have understood this one. So let's go for next question again. Yeah, question number 1.6. Carefully you should read this question. Careful measurement of the electric field at the surface of the black box indicates that the net outward flux through the surface of the box is 8 into 10 power 3 Newton per Newton meter square per Coulomb. What is the net charge inside the box? And if the net outward flux through the surface of the box were zero, could you, could you conclude that there is no charge inside the box? Why and why not? So again, you just use pause the video and just try to solve by your own this type of problem. I hope you have understood the question. So what they have given, so they have given net outward flux through the surface of the body. So they have already given phi, that is phi value is equal to 8 into 10 to the power 3 Newton meter square per Coulomb, right? For a body containing net charge, so let us suppose there is a body and it contains some net charge, right, like q. So we need to find q. So phi is equal to q by epsilon naught. Also we have done this one, right? So from here, epsilon naught is the permittivity of the free space, so epsilon naught value is equal to 8.854 into 10 to the power minus 12 Newton inverse Coulomb square meter square. Now from here, what we need to do, we need to find a charge. So q is equal to phi into epsilon naught. So just put the values. Phi is equal to 8 into 10 to the power q into 8.854 into 10 to the power minus 12. So finally we will get the value, and this value will be around 0.07 microcoulomb. Therefore net charge, so this is your net charge. This is net charge, right? This is net charge. I hope you have understood this one. Now the second part of the question, they are saying that if the net outward flux through the surface of the box were zero, could you conclude that there were no charges inside the box? So let us suppose there is a box. Let us suppose there is a box. Okay, and out of this, see what happens. What is if the net outward of the flux? So let us suppose this is a outside. So net, if it is going inside and it is coming out. So if net flux is zero, net flux is equal to zero. So it means that charge inside will be also zero. Charge inside will be definitely zero. So I hope you have understood this question. So let us go for next question. Now before that we need to read the question properly. A point charge 10 microcoulomb is at a point charge 10 microcoulomb is at a distance 5 centimeter directly above the center of the square of side 10 centimeter as shown in a figure. It means that there is a point charge at this which is at a distance of 5 centimeter directly above the center of the square of a 10 centimeter shown in a figure. What is the magnitude of the electric flux through the square? Think of the square as one face of the cube with the edge this one. So we need to find a, they are just giving you hint that you need to think like that this is the cube, and if there is a cube inside it, so how to find a flux inside the cube, right? So how to do this? Just pause the video and think about to solve this type of problem. So just give it. Now let us consider this as a cube. So there is a cube. If you have gone through the questions, so we can say that there is a cube. So let us suppose there is a cube and use Gauss concept, and there is a charge q. So flux will be equal to charge enclosed by epsilon naught, right? So total charge enclosed by epsilon naught. Now total flux is equal to this one, right? Now flux for one phase. If you want to find flux through one phase, flux through one phase. So how you will do this one? So flux through one phase, this will be charge enclosed by epsilon naught into 1 by 6, because there are six side, right? Now we need to put the values. So let us put the values. Charge they have provided you as a 10 microcoulomb, right? So let us put here the value of the charge. So E naught epsilon naught is equal to permittivity, and this is equal to 8.854 into 10 to the power minus 12 Newton inverse Coulomb square meter inverse square. Now charge also they have provided you as a 10 microcoulomb or 10 to the power 10 into 10 to the power minus 6 coulomb. Now put the values so that we can get the values. So if you start putting, so charge will be flux will be equal to 1 by 6 into 10 to the power minus 6 divided by 8.854 into 10 to the power minus 12. Now when we calculate it, so what we are getting, so flux will be equal to 1.88 into 10 to the power 5 Newton meter square Coulomb inverse, right? So I hope you have understood this one. So let's go for next question. Next question, just read the question so that you will able to get to know. A point charge of 2 microcoulomb is at the center of the cube. Gaussian surface of 9 centimeter on a edge. What is the net electric flux through the surface? So we need to find so again try to pause the video and go through it, and you try to solve this one. So I hope you have gone through this question. So what they have provided you the data they have provided you as a point charge is there, and it has a 2 into 10 to the power minus 6 coulomb. The charge is at the center, so center of the cube, so it is a Gaussian surface. So what is the net electric field? So net electric field, we know that net electric field will be equal to charge enclosed divided by epsilon naught. So charge enclosed is 2 into 10 to the power minus 6 coulomb divided by epsilon naught, means 8.854 into 10 to the power minus 11. So while calculating, you will able to understand that how much you are getting. So if you do the calculation, so it will be 2.26. It will be approximately 2.26. It will be approximately 2.26 into 10 to the power 5 Newton meter square per coulomb. So I hope you have understood this one. So I hope you have understood this problem. Let's go for question number 1.19. So in 1.19, a point charge causes an electric flux of this one to pass through a spherical Gaussian surface of 10 centimeter of radius centered on the charge. If the radius of the Gaussian surface were doubled, how much flux would pass through the surface, and what is the value of the point charge? So again pause the video and try to solve this problem by your own. See there, in question part 1, what they are asking. If the radius of the Gaussian surface were double, how much flux would pass through the surface? So we know that q net is equal to charge enclosed divided by epsilon now. Now either you are increasing the radius, decreasing the radius, so it does not depends upon the radius. So net flux does not depend upon does not depend upon charge enclosed. Sorry, does not depend upon area or radius. So net flux will remain same. So net flux will remain same. I hope you have understood this one. Remains same. Yeah. Now, what is the value of the point charge? So they have provided you everything, so we need to find the value of point charge. So let's go and solve this one. So q is equal to phi into epsilon naught. So phi they have provided you as a -1 into 10 to the power cube Newton meter square per coulomb into epsilon naught means 8.854 into 10 to the power into 10 to the power -12. So basically when you calculate it, so finally you will get as -8.854 into 10 to the power -9 coulomb. So this is equal to -8.854 nanocoulomb. So I hope you have understood this one. So let's go for next question. Next question, uh, conducting sphere of a radius 10 centimeter has unknown charge. If the electric field 20 centimeter from the center of the sphere is this one and a point radially inward, what is the net charge on the sphere? So we need to do this one. So think again, you just pause the video and try to solve the problem. Now let's solve it. So this is question 20th question. So see, there is a conducting sphere. So let's try to go step by step. There is a conducting sphere of a radius of 10 centimeter and has an unknown charge. So let us suppose the unknown charge is q. The electric field at a 20 centimeter. So they are asking electric field at 20 centimeter from the sphere. Okay, sorry, they have given electric field at the 20 centimeter is 1.5 into 10 to the power cube Newton per coulomb, right? We know that electric field E is equal to kq by 1 by 4 pi epsilon naught kq by r square or d square, whatever. Now from here we can easily find out q charge, that is charge is equal to E into d square divided by k. So electric field they have given you 1.5 into 10 to the power cube into d square means distance they have given you 0.2 whole square divided by k means 9 into 10 to the power 9. So this is the simple values. So I hope you have understood this one. So when you solve this type of problem, so what we can get, when you will solve, so what you will get charge. So let us calculate it or try yourself. So this will be approximately 6.67 into 10 to the power 9 coulomb or 6.67 nanocoulomb. So I hope this answer will be fine. So this is the charge. Now you are thinking that what type of polarity of this charge is. Since they have given or they have told you that radially inward means electric field is going radially inward, this will be only possible when this charge is negative, because if charge is positive so it will be radially outward, but whenever charge is negative so it will be readily inward. So I hope you have understood this one. Now question number 1.21. A uniform charge conducting sphere of a 2.4 meter diameter has the surface charge density of 80 micro Coulomb per meter square. Find the charge on the sphere. What is the total electric flux leaving the surface of the sphere? So just read the question, pause the video, and try to solve by your. Now let's solve this problem. Again, you try to read so that you will able to solve this type of problem. A uniformly charged conducting sphere. So there is a sphere which has been uniformly charged, a sphere of a diameter. So they have given you diameter as 2.4 meter and has a surface charge density, that is sigma. They have provided you as 80 into 10 to the power minus 6 coulomb per meter square, because they have given you the unit in micro coulomb. Now the total charge on the surface of the sphere. So total charge, so we know that total charge q is equal to sigma into area. So from here we can definitely find out radius is equal to 1.2 meter. So sigma, they have provided you 80 into 10 to the power minus 6 into radius pi into surface area will be 4 into 4. So let us do it for properly. So it should be 4 pi r square. So this is your 4 into pi means this one into r square means 1.2 whole square. So try to calculate this one. Just pause the video and do it by your own. So basically you will finally get 1.447 into 10 to the power minus 3 coulomb. Therefore the charge is this one. So this is the charge. Now part B video of this one. A we have done. What is the total electric flux leaving the surface of the sphere? Electric flux. So how you will find electric flux? So total electric flux will be charge enclosed by epsilon naught. So total flux is equal to charge divided by epsilon naught. So total charge is how much? Total charge is 1.447 into 10 to the power minus 3 divided by epsilon naught means 8.854 into 10 to the power minus 12. So when you calculate it, so you will get 1.63. You will get 1.63 into 10 to the power 8 Newton per coulomb meter square. So I hope you have understood this one. So this is the answer they required. So I hope you have done this one. So let's go for next question again. So next question is, read the question. An infinite line charge produces a field of this one, electric field of this one at a distance of 2 centimeter. Calculate the linear charge density. Linear charge density. So how you will find linear charge density? So what they have provided you? Electric field as 9 into 10 to the power 4 Newton per coulomb, and the length they have provided you 2 centimeter or 2 by 2 into 10 to the power minus 2 meter, right? We need to find the linear charge density, that is lambda. All need to find, just pause the video and try to solve this. I have given you lambda they are asking you. Now you remember the formula, electric field is equal to lambda by 2 pi epsilon naught into d, right? D is the distance, right? So this is the distance. They are not given. See, this is the distance. This distance they have provided you. Now by using this, we can easily find out lambda. So from here, what you can use, lambda is equal to E into 2 pi epsilon naught into D. So electric field is equal to 9 into 10 to the power 4 into 2 into pi into epsilon naught, means 8.854 into 10 to the power minus 12 into diameter D is equal to 2 into 10 to the power, not diameter, that is the distance. See, let us suppose there is an infinite long wire and we need to find the electron linear charge density. So this is the distance. At this point electric field is E. So by using this we can use the formula so to find out the electric field. Now let us suppose it is given as 2 into 10 power minus 10 and this is equal to lambda. So you need to calculate this one. Okay, one more thing you can do for a shortcut or good calculation you can do is that 2 lambda divided by 4 pi epsilon naught into D. So this will be 2 lambda divided by 4 pi epsilon naught, means it's k into D. So from here what we can say that lambda is equal to E into k into D divided by 2. So basically, see, one more again I have done the mistake. Try to rectify it. So let's erase all this. I will give another formulas so that you must not be confused on this one. So let us see here. Electric field E is equal to lambda divided by 2 pi epsilon naught to D. Now we can also write here 2 lambda divided by 4 pi epsilon naught into D. Now 1 by 4 pi epsilon naught, K is equal to 1 by 4 pi epsilon naught, and this is equal to 9 into 10 to the power 9 Newton per Coulomb square. So this is the value we can use here. So from here, 2K lambda is equal to by D is equal to E. So from here lambda will be equal to ED divided by 2K, ED divided by 2K. So E is equal to 9 into 10 to the power 4 into K. Sorry, D is equal to 2 into 10 to the power minus 2 divided by 2 into 10 to the power 9 into 9. So when we calculate it, so 9 got cancel out, 2 got cancel out. So this will be 10 to the power minus 7, or we can also say that 10 into 10 to the power minus 6. So it will be, it's one more thing, it's given as C, 9 4 minus 2 2 minus 7, it will be in minus 7. So basically what we are getting, just calculate it by your own, so you will get the result. As a result, final answer should be approximately 10 microcoulomb per meter, right? So try to solve this. Next question is the two large thin plates. Let us suppose there is a two large thin plates. Two large thin plates, thin metal plates are parallel and close to each other. One on their inner face, the plates have the surface charge density of opposite sign. So let us suppose there is a two inner plates, two thin inner plates like this. Okay, and it has surface charge density plus sigma minus sigma like this. Okay, of opposite sign of a mag, and the magnitude is how much? Density is how much? Density is equal to 17 into 10 to the power minus 22 coulomb per meter square. What is E? Electric field in an outer region of the first plate and in the outer region of the second plate and between the plate. So we need to solve this. So just pause the video and try to solve by your own. So they are asking region. See, there are three regions, 1, 2 and 3. They are asking charge in the outer region of the first plate, the outer region of the second plate. So if you observe this, see, region 1 and 3 is not enclosed by the plates. So electric field at this region will be 0, right? Electric field at this region will be 0. Now the part C, between the plates. If you want to find electric field between the plates, so electric field is equal to sigma by epsilon naught. So just put the value sigma. Sigma they have given you 17 into 10 to the power minus 22 divided by epsilon naught means 8.854 into 10 to the power minus 12. So while solving this, so you will get 1.92 into 10 to the power 1.9 minus 10 Newton per coulomb. So I hope you have understood this one. So this electric field is for region 2. So I hope you have understood this. Next I will continue for second chapter. Thank you for watching our video. I hope you have enjoyed the session. Thank you.